So in this video, I'm mainly going to talk about compound inequalities, but I also want to kind of combine it with interval notation. So before we get going on the compound inequality part, let me just remind you, or maybe tell you for the first time, when you have an interval of a number line, you either use parentheses or brackets, and parentheses mean that you want to exclude your endpoint, that particular endpoint. A square bracket means you want to include that endpoint. And parentheses corresponds to using an open circle on the graph, and a bracket corresponds to using a filled in or a closed circle on the graph. And whenever you use infinity or negative infinity, you're always going to use a parentheses because you can't ever include infinity or negative infinity. So for example, let's say I had something maybe look like this. Maybe I'm going from -2 up to 5, and I am going to exclude -2, but I want to include 5. So, oops. And I want to have the numbers that are in between. Oh, stop it. Okay. So then all the numbers between -2 and 5, excluding -2, including +5. This would be, since I'm excluding -2, parentheses -2. And then comma, I want to include 5, so when I write the 5, I'm going to do a bracket. So it's kind of an abbreviated way to write down this region of the number line, where you just put the endpoints and you use parentheses and brackets to explain or show whether you want to include or exclude that particular endpoint. By the way, we could write this as an inequality, as we keep x in the middle. This is the easiest way to do it, in my opinion. So x is in between -2 and 5. Pretend that's all on the same line. That looks, this -2 is floating up a little. To show that -2 is not included, I would just use a simple less than. But for 5, I would need to use a less than or equal to show that I do want to include the 5. So this is called a three-part inequality, and it's saying that x can be, or x is between -2 and +5, including 5. So another option, or another thing you might see, I guess, is let's say we have just 5, and we want to show that we can include 5 and then any number less than 5. So you might see this written as x less than or equal to 5. Since we don't have a left endpoint and we can go forever, we need to start with negative infinity. So you always want to go from left to right with your interval notation. And remember, infinity and negative infinity should always get a parentheses. So then I'm going to do comma 5 bracket. Okay, so this says all the numbers up to 5, including 5. So let's see then how this is going to work when we have a compound inequality. So a compound inequality is when you have two inequalities stuck together with an and or an or. So we're going to look at I'm going to try and do a bunch of different examples. So over here I'll stick to and then over here I'll use or, and we can kind of compare and contrast. So for this first one, x greater than or equal to -7 and x is less than 8. And is the more restrictive of these two words. And means only overlap. Both inequalities have to be true for a number to fall into the solution set, I guess, or the graph of this whole compound inequality. So I want to figure out what are the numbers that are greater than or equal to -7 and also at the same time less than 8. So and means look for overlap. Overlap only. So to figure out where that is, let's graph both of these on the same number line. Alex, I think, shows you graphing them on two separate number lines, but I think that makes it more difficult. And so your number line doesn't need to be too fancy. Just put your two endpoints up there. And so we've got x greater than or equal to negative 7. So that means include closed circle on the negative 7. Greater than or equal to means shade to the right. But I want to be able to see where the overlap is. So I'm going to kind of draw a line up above going to the right. Then x is less than 8. This would be an open circle, and now it's going to go to the left. And so again, so that I can see overlap, I'm going to just sort of draw up above a line going to the left. And so now I can see that the overlap happens only between the two numbers. So it's actually what you would have for your final answer would just be in between here. So it would look like, when we clean it up, this. So just that bit. And so I could write this a little more simply, instead of using the word and, as negative 7 less than or equal to x less than 8. Or I could use my interval notation and use a square bracket on negative 7, comma 8 with a parentheses. Okay, so then let's jump over here and talk about OR for a second. So OR is much more flexible, and OR is going to include a lot more of the number line than the AND. Basically, it's everything you shade. So everything shaded, not just the overlap. And so for this first one, we have x greater than 7. So open circle and then go to the right. Now you could do the same thing where you kind of draw a line up above, but if it's an OR problem, then you don't care where the overlap is, so you don't really need to see it. So I'm just going to shade right on my number line. And then I have x less than or equal to negative 1, so put the negative 1 over here. It's going to be a closed circle because less than or equal to, and then we're going to go to the left. And so I see, actually I don't have any overlap. And it's just two separate intervals. And so this is kind of the weird situation, or it's a weird looking interval, I guess I should say. This is where we're going to have to use this union symbol. So it looks like kind of like a capital U, and that's what it's supposed to look like for union. And we're going to write each of these intervals separately. Now, for this topic, you don't have to, you're not doing interval notation, you just graph it on the number line and then you're done. So for this one, this is the graph, because there's no way to like simplify this or combine it in any way. But just, you know, for your information for later intervals or later topics, I'm going to go ahead and write, okay, here, let me move this thing down a little out of the way. So the interval would be from negative infinity up to negative 1 with a bracket, and then union parentheses 7 to infinity with a parentheses. Okay, so let's see how kind of the and the or stuff can look a little bit different, or the different cases you might see. So let's say we had, going back over here to the and, let's say we had that x greater than 7, so the same thing that we got over here, but this time it's and x is less than or equal to negative 1. So x greater than 7, I'll put my 7 over here, and open circle, go to the right, then negative 1, close circle, go to the left. Remember, for and, we want overlap, but there is no overlap. So since there's no overlap, this would be the numbers that are greater than 7 and also less than or equal to negative 1, there aren't any. So you could say no solution, or the empty set, or it's just an empty number line. So that can happen when you have an and, that you end up with an empty set. Only with and can you end up with an empty set or an empty number line. One more thing that you might see is, what if you have your two inequalities like going in the same direction? So let's say we had, I don't know, x greater than 7 and x greater than 10, something like that. So then we have 7, we have 10. Both of these are not included, so we use open circles. And maybe I'll go underneath here. So greater than 7, I'm going to go to the right. Greater than 10 is also to the right. So notice now the overlap starts with 10, right? Here is where we see overlap. So the overlap would just be going from open circle 10 to infinity. So that would be the simplified version of this. It turns out the x greater than 7 is kind of redundant. If you're greater than 10, you're already going to be greater than 7. There's no need to even say that. So the final graph answer would just be from 10 to infinity. And then the interval notation would be parentheses 10 to infinity parentheses. Okay, so let's then look at a couple of these when it says or. I think I'm not going to need that one. Let me delete that. So let's look at, stop it. Okay. That very first one we did up here, but change the and to an or and see how that changes things. So x greater than or equal -7 or x less than 8. So what would that look like? So here's our -7, here's our 8. And remember for or, we don't care about overlap, so I'm just going to shade right on the line instead of doing all this business. So greater than or equal to -7, close the circle, and then we're going to go to the right. Less than 8, open circle, go to the left. And so remember, or is everything that you shaded. Well, look what we've shaded. The entire number line is shaded. So that means the answer, or the solution set, it's the whole number line. And to write that as an interval, it's just -infinity to +infinity, and you use parentheses. So this can happen with or, and only with or will you end up with a whole number line shaded. All right, so one more. Let's say this guy over here, this x greater than 7, but make it or x greater than 10. So how does using an or change the final outcome? So there's our 7, there's our 10. So both of these are open circles, and both are going to go to the right. And so now, since we're using or, and we want to take everything we've shaded, now instead of starting at 10 for our final answer, we're going to start at 7. Numbers that are greater than 7 or greater than 10 are included if you just say greater than 7. That's the simpler way to think of this, is that it's just x greater than 7. And so then your number line, your final graph would be just open circle at 7 and shade to the right. You don't need to have anything to do with the 10 on there because it turns out it's redundant. And the interval notation would be from 7 with a parentheses to infinity. So for and, it's kind of the inside bit that we ended up with just the overlap, but for or, it's overall basically what you shaded.